Jack of all trades.
And networks are always artificial if they're
You're going to edit that bit out, right?
like social networks.
Okay, so we're happy to have Tom here today, everybody, and he's going to be telling us about how to operationalize things. And this is kind of a little bit of a proto presentation about some of the stuff he's going to be working on for his dissertation. So take it away, Tom.
Okay, so we're talking about operationalizing agent-based models, introducing Mesa packages. All right, there's the also present or required agenda slide. All right, so then this is, so we're going to talk first, right, emergent behavior. So what's observed? I've not done a rigorous study, all right? However, what's been observed in both the classes here at the Computational Social Science program, classes online, like through the Santa Fe Institute, as well as in the literature, is that people use the agent-based modeling platforms like Netlogo, like Mason, like Swarm and Repast, all right, but they're always coding that from scratch, or they're going in and hacking an existing model and adapting it to their particular angle. All right, but where you're actually citing, say, an agent cognition, all right, that you pulled in from somebody else that, say, is does artificial intelligence, for example. All right, so where the parts of an agent-based model that you might pull in to your model, say opinion diffusion, a landscape, right? I've been reading a lot of ecological models right now of the Little Jones Creek and Northern River. All right, so that's what, right? So that's this, that's the epic picture. But what I want to get to is this, right? So what's possible, right? Saying, so optimized libraries of aspects of ABMs that can feed into those platforms. All right, it's already standard in machine learning and artificial neural networks. All right, and then so the goal, right, you got to have an objective. So the goal, right, to see a change in the emergent behavior, the students in 600 or 610 are actually citing these other optimized codes when they're building their models, and they're building more complex and kind of exciting models as they research different aspects of agent behavior.
So, go ahead.
Yes.
So you're not the only person to talk about this, right? So in the language and language change community, you've got people like Bell, Filatov's talked, I think, about this, and many other people have talked about this reuse of code, right?
Yes.
And I don't know if I'm jumping ahead of myself or jumping ahead of your talk, but one of the challenges there is documentation, protocols, and things like that.
Well, I will show you an exciting example of at least one. I'm kind of going for the used car salesman here, but I'll show you an example of one possible way to do that. I will say it's somewhat nascent, right? So it'll evolve over time. But I will get to a full up example where you can do it. Right? We can at least pull in one algorithm.
So go back to your previous slide. You said already standard for machine learning and neural networks.
Yeah.
So are you using a very loose definition of standard, because there's at least a dozen standards out there for that?
Well, so I mean by standard use, not like engineering standards.
So you don't have, by standard you mean you don't have to build it from scratch?
Yes.
You can just call it like.
Yeah, common behavior.
Okay.
So standard operating procedure.
Because I mean, well, even standard operating in machine learning are different if you go between TensorFlow, or use the Keras framework around it, or if you're using PyTorch. Those are all going to be a little different from each other. So it's not standard. It's standard in the sense that you don't have to write it from scratch.
Yes.
But it's not standard in the sense that you can do it the same way.
Standard behavior, not standard in the sense like an engineering framework.
Or maybe, but is there a further subtle point though, that it's a difference between kind of like a standard versus the standard versus no standard? And I think your point here is simply no standard in 600 or 610 versus having some kind of standard.
Well, I mean, you can replace standard with already an emergent behavior in machine learning and neural networks, right? There is no say again?
The building block.
Yeah, exactly, right? I mean, it's like a fundamental aspect of object-oriented programming, right? The data science has not come up with an all-knowing machine learning algorithm, right? Instead, they're producing a herd of data scientists to use code that's already been optimized and built by the kind of leaders in the field. All right. So give an example from TensorFlow. Right. So this is just a standard gradient descent optimizer. All right. When you look at the TensorFlow code, all right, for just the first layer, there's 7 classes that consist of about 11,400 lines. Right, now I will concede that when you run this, you're probably not using all of those because it's a library, but the TensorFlow library is used, or is huge, All right, and I'm not a computer scientist to be able to do this. So what I get to do is that one line of code over there, optimizer equals TensorFlow dash train dash gradient descent optimizer. All right, so I'm like this little kid down here, right? I'll let you pick which one, all right? Who can pull in, you know, this kind of elaborate matrix algebra, all right, and leverage it so I can explore my particular phenomenon of interest. All right, so now for an example. All right, so what I can talk about is I did actually for 610, and I could not reproduce the code and article I was basing it off of, so I actually go back over the summer and go back to the original literature and kind of write it from scratch. But it's the bilateral Shapley value, which is part of coalition game theory. All right, and so this, just the basic thing is how are agents going to coalesce into larger groups as they make decisions. The one I originally took it from was a transmission line sitting example, where they were trying to figure out, a power company in Southern California was trying to figure out how it can make sure that as it decides where to put this like massive transmission line, that it's not going to be overwhelmed by groups of people coalescing in their neighborhoods, and then they have to spend millions of dollars rerouting it because they get, you know, like some kind of county or city ordinance passed that they can't put it through there numerically. But you can also use it for other things, right? Like, so politicians supporting a bill, how will they coalesce based off their preferences for an issue and who's in power, right, and whether or not that bill will fail or succeed, all right, villagers in civil conflict, all right, or in my case, the impact of U.S. support, all right, and the examples go on and on. Any case where you could say how are different people gonna come together to do something or not do something or fight with each other, all right, and then here's it's just like a picture. Here's your visual, all right. That doesn't come off very well, but. Really, so this is just a toy example now, all right? And this is on the GitHub page for it, all right? But the whole thing can now be run in about 50 lines of code. If you take out the comments, it'll probably be about 25, all right? So what's happening up here, although you can't read it for I guess the quality, what's happening up here is I'm instantiating each agent just randomly with an affinity, so a preference for something, and then a power, which is based off a just random number, I think it's uniform distributed, if I remember correctly, of economic and military strength to give them a power value, right? So their economic military strength averaged together to give a power value, all right, and then that feeds into the execution here, right? And one line of code, I run it, and then it poops out how all those how that's the technical term, how all those agents come together, all right, and form groups based off their power and their affinity, right? And in this case, well, I'm just kind of getting into the weeds. All right, so that's
I want you to know I noticed the pun.
Yeah.
That military strength is uniform distributed.
Well, it's just an example. However, in this case, I did not do that. So this was a study to apply it. So the research question that I was asking was, what would be the impact of U.S. support if we decided to intervene in the Libyan civil war? All right. So how would that impact how these groups coalesce into people? All right, and I kind of did just a classic analysis based off sparse information. I looked at the economic resources, who owned what, where the military equipment was, based off kind of battles that had occurred, who was stronger, and using that I did a qualitative assessment, and then based off a review of the literature on how the tribes typically align and where the tribes are at, which was a whole other exciting thing, and it would be highly argued, who were the tribes and what were they? I instantiated, I think it was 165 or 160-ish tribes, all right, gave them their affinity of power and ran that through it, and then I calibrated it based off that. There's also another version where I actually, instead of giving them the military and economic resources, I based it off GIS data, whereas based off where the oil wells were, where the roads were, because the primary economics is illicit trafficking or trafficking of illicit goods to and from Egypt, all right. And then the affinity was still based off that qualitative assessment, right? So then all that fed into it. All right, and again, that's just the entry code now, so that's a little bit longer, and then it goes through the bilateral Shapley value, all right, and then the other trick is now you got to interpret the results, right? And in this case, there's two parameters. There's the marginal effectiveness parameter, right? So how effective is it when two groups of people come together, right? What's the, I'm going to forget the term now. What's the economy of scale that they get by joining together and trying to do everything themselves, right? And then a compromise parameter, right? So how much are they willing to compromise their preferences based off forming the alliance? And based off this calibration, I did get, all right, what I interpreted as a pretty accurate output, right? So the right tribes coalesced with the right people. So based off known alliances in Libya at the time we assessed it, those tribes were grouping with each other, all right? And we did get this east-west split that we're kind of seeing in Libya, all right? There's absolutely certain complexities that it can't capture, all right? Which is that the east, which is more populated, I would contend it is more loosely allied than the west, but I did get some pretty good results. And then at that point, I was able to feed in essentially a huge amount of support to one group or multiple groups to see what that impact was. And the interesting impact was that if the U.S. put a huge amount of money and military power to a tribe or group in there, they were less likely to compromise, and they formed a smaller, more powerful minority. All right, so that was the impact. All right, and that's going to become important later. All right, but we'll get to that. But there's lots more possibilities, right? So that's the idea. And I forgot to tell you, this is my rehearsal for CAPS, so it's actually be fairly short. It's only be about 30 minutes or so. So make sure I get in time. All right, we can start putting stuff together. So actually, the bilateral Shapley value was used in another article by Zinnegang and Peter Zagorowski out of Claremont. And Zagorowski is now an Army officer. All right, where they put weather variance on top, that then fed into the agent situation, right? So how much power they had based off the impact on crops and things of that matter. All right, that then fed into the coalition thing, and then they threw some conflict onset theory on top of that to see when civil war might break up based off weather variance, all right? And then they looked at the results. All right, but there's other things you can do, right? So that's kind of theory mix and match. What if you put in different cognition into those agents so they perceive things differently, right? So you got PECs, fast and frugal, evolutionary algorithms with Hebbian learning from the elk migration in Yellowstone. All right, or usually so that IBMs out of Railsback that they've done extensively, the Little Jones Creek, where now you can have that landscape, put in the fish with their processes, add the frogs on top of that, or somebody else could come in and kind of piece all these together and over time build up that whole ecosystem.
So like multi-level modeling?
Yes. Right.
As Netlogo calls it.
Yeah. And then the other thing is, one benefit is that with Python, I guess you do this with everyone, is like NumPy I think is actually in C, not in Python, and so you can get speed on the backside depending on how well developed that particular library is by linking it into C or C++, C# or Java. All right, so that's Python and Jython. All right, so how's it work? All right, and this is where the multiple screens come in, which I feel obligated to make sure I got at least 3. All right, so first will be a package on GitHub, and then a link on Mesa. So on this screen here, all right, is the Mesa wiki page. All right, so you have Mesa packages, which is, or you got Mesa, the ABM platform, all right, and this can be called in. So if you just click on packages, right, that's where we're starting out with, just a list, right? So there it is, the bilateral Shapley value, all right, it's in coalition game theory, kind of talks to you what it's about, and then that will link you, all right, into the detailed description. So then this goes to my GitHub page. It says, what is a bilateral Shapley value? All right, and then, so here's the example code. All right, you have different methods. Here's your flow chart to show you how it works. All right, and then I think this is key as I'm always trying to link conceptual understanding, which is proving crucial for my research right now. What's that conceptual, and then once you instantiate it in code, is you always have to make choices. All right, so I felt it was I was obliged to at least say what those choices were and what the weaknesses with my particular instantiation of this model was. All right, and then put it out. So going to your question, you know, what does this look like? So I mean, this is quite frankly just kind of a first shot. All right, and then I'm sure over time, right, it'll standardize as Jean-Luc would say, the neats will take over from the scruffies. All right, and they'll say, hey, it has to look like this. Right, this is this, yeah, like so ODD or something.
So that you have, yeah, I was going to ask you about the protocols. You have
Yeah.
ODD plus D.
Yeah.
You have some M behavior thing now for describing the behavior of agent-based models. Why have you rolled your own protocol here?
Well, so because the purpose for this was to make it so people can use it, right? So look at like so the ODDs. Right, so look at so the ODDs. It's 40 pages, right? Like one of yours is 40 pages,
Yeah.
right? So this is really focuses on like the brief overview.
So what in here does it say what a time step is?
It does not, because it's you can add it adds a time step because
Does it say what about stochasticity is used? Because these are elements in ODD that have to be
Yes.
said, right? But time step, no, because stochasticity.
yeah.
That's not.
Then again, ODD doesn't say anything about activation.
No. Oh, it does. The new one does.
A wee bit.
Yeah, the ODD.
The new one.
Yeah.
Yes.
So that thing says I will absolutely concede your point, and that this was just to say, hey, this is effectively what it is. With time steps, this is like a part. So this is where you might run into some issues, kind of having the discussion now. But where you might run into some issues, because this is like a part that you might put into larger time steps, right? So I might say, hey, I'm an agent. I'm looking at these people right now. So let's take just off the top of my head, take your model, right? And something just went wrong. You know, I got to form a coalition, right? Immediately. So these are the people in my group. Based off these inputs, I'm going to go with these folks. All right.
What about
You know,
when you say like when you're looking around your thing? Sorry, temporal issues is one thing with ABMs, especially when you have like a pedestrian model designed for seconds versus an urban growth model that's like years, right?
Yep.
Then merging those two together, what's the temporal step?
Yeah, well, and I think, so I will say that, and I mean, this kind of gets to what happens later. What does it look like? And then how vast is the particular aspect that you're putting in? Because I can tell with this one, I mean, really what it is computational combinatorics, as you pointed out when you reviewed my paper, right? It's just, everybody's, like with this one, everybody's looking at everybody else and then making the best choice. And then you can make some efficiencies by saying, well, we know these aren't going to work, so you kind of get rid of those. The challenge will be, I'd say at the very least it's going to be on a case-by-case basis, because this could be very local, or it could be, you know, like as in the case of the Libya thing, like the primary aspect of the model. Right, you're really just looking at, well, what happens? It's 160 odd tribes. That's too many for me to comprehend all these potential alliances. So what happens if I do it? So I think it'll depend on a case-by-case basis, and I have no doubts that this is, you know, like the first shot to hopefully get some movement going. And then over time, the mistakes will be made, and people will figure out better ways to do stuff. And if anybody ever uses this, they'll tell me how it sucks and that I need to improve it, and then I'll do the issue and make it better. Right? The other aspect of this, though, right, is you're coming from, as I said, the history major, right? Going through this program is how do we get, you know, people from like the social sciences that don't necessarily have extensive coding backgrounds to do it. So this is still got to be pulled into Master Mesa. This is one of the branches right now. But, right, so that's what this is. So it says, hey, the how-to, this is kind of what it's all about. Right, these are the benefits of this way, right? That goes to building blocks, as you said, sir. All right, and then it's got the two other aspects, right? So the user guide, right? You want to pull these in. You're a student 600 or 610. Haven't really played with this stuff around, right? They'll give you some, say, hey, select a package, establish an environment, right? Now I put that in because I horribly misused virtual environments and didn't understand them when I first started. That's my desperate, and then you install the package. If it's a highly developed package, it'll be kind of standard pip install through Mesa. If it's one like I just showed you, then you can install it directly from GitHub, right? So now you're off and running with your packages in 3 steps. All right. But then the other aspect is a how-to guide, right? So this gets you, in 8 steps, will get you from, hey, I got a module I think other people can use, to sharing it, so other people can use it, right? And takes you through. One of my biggest complaints is they don't have this stuff consolidated, so this consolidates it. Things like, hey, I didn't know you could just do this requirements thing, and that'll pull everything in for you. And that'll become another problem if this gets diverse, is where you might have one library that's compatible with Mesa, say I guess around like 0.5, another one that's compatible with Mesa 1.2. So you gotta you're gonna have at some point those issues if the ecosystem gets dense enough. Then the next level, which is this walks you through the guide to how to get into the PyPy library, so how to get to that standard. So that way it's part of the standard library, which has some other implications, and then you can use it for everybody. And at some point that'll probably be extended to talk about things like testing and kind of pass on to the social scientists the dynamics of software development. All right. So in this case, you got mine on GitHub. You got a link on Mesa Wiki. Say, hey, this is what's available if you want to pull it in. It also has in my humble opinion, a very neat. Actually, Jackie fixed most of it. A very neat, like kind of consolidated way to either use it or develop your own if you have an interest, and then you're the happy user there in the middle. So so then what's the future? So right now it's just on the wiki. The kind of I guess is checkpoint is at 10 packages. So look at something like a little bit more robust if this starts to gain traction. Jackie likes to use Django, which is a website framework. I haven't used that one too much, but recently I have been playing around a lot with TensorFlow and scikit-learn. Right, both very robust libraries for neural networks, and then machine learning, where it gives you all sorts of information. All right, so why is this more important than convenience? All right, so I'd say because science, right? So reproducibility, right? Others can run it and see if they get the same result, right? And that was the problem I had. We're actually originally using this and looking at it, so I could care about how populations coalesce as groups. Was that seeing the Netlogo model and that code, we were unable to replicate it, just looking at it. Now they got the whole code, and they can mess with it as they please. All right, and then replicability. All right, so can you apply it to other phenomena? Right, so this is where I would contend. Right, so I use a Libyan model. One of my conclusions from that was that by putting in a huge influx of power, right, it reduces that person's incentive to compromise and to form alliances, which caused a bunch of the other groups to go to the opposition. All right, I would contend at some level that's exactly what happened in Afghanistan, right, where we supported the current the Karzai administration when it came out, right, and that reduce their incentive to compromise to include providing basic local governance at the local level, and they did it, right? But I could be full of crap, right? But now somebody else could just take that code and say, all right, let's see. And if they do the roll up of the Afghan tribes, do the same thing. Can they reproduce what they think that happened in Afghanistan, as well as that kind of same phenomenon? Which I would contend would be huge for foreign policy. If you say, hey, if we start supporting people, this might have some negative consequences because now they stop compromising. All right, and one of the interesting things, if you start supporting multiple groups, right, then everybody then it goes back to the way they would have formed if you weren't supporting. All you're doing is making certain groups more powerful. All right, and this one doesn't contend with who's going to beat who based off military power and tactics. All right, so those two are both from a PNAS opinion paper. And then I would add to this is research, right? It's easier to find out why the results could not be reproduced, right? So if somebody else used the exact same code on, say, an Apple, right, and they got vastly different results, right, then they're like, well, what the hell is going on here, right? And then you can start to peel back that onion and figure out what's going on, all right? Or if you couldn't replicate it, so hey, this actually did work in Libya, but it didn't work in Afghanistan. What was the difference? Right? Was it just the data inputs? Was it, does it only work under certain conditions and not others? All right, which will hopefully lead us to. All right, and then this quote from Grimm et al.'s pattern-oriented modeling. All right, which is where I'll just focus on the bottom part. The theories of complex systems may never be reproducible, like in physics. All right, so you're going to have will it be like natural selection? We have conceptually simple mechanisms. And I will brazenly contend, that more people kind of searching, going through that search space, piecing things together, there's a higher probability that that will come out. Right, if there are some conceptually simple mechanisms that are constantly seen across disciplines. Right, if all of a sudden IBMs are using similar processes that foreign policy groups or ecological and foreign policy start using the same algorithms as their go-tos. And that's it.
Good. Pretty close.
Joe.
I'm not
Oh, he's gonna clap.
Oh, there's a-
I have one question.
yes, sir.
Your whole, well,
I can
several
show you the code on this one too, if you want to see the actual code underneath it.
I'm good.
Okay.
One of the big premises of this idea is people are going to share code.
Yes.
Discuss. Because that's one of the major problems.
Yeah.
You know, if you look at Netlogo, if you look at Open ABM, it's relatively successful.
Yeah.
When Stefan did his thing, it was like nearly 90% of the Netlogo models that were just one-offs.
Yeah.
So how are you going to get community buy-in? I guess.
So let me say, I'm going to put it in a context I understand, just because in my mind this is where it works, but this does not reflect the views of the U.S. government or Department of Defense. However, what I would say is it becomes a forcing function, right? You start contracting out, right? So you got University of Central Florida and those guys that were building stuff for DARPA, right? And I didn't know Python was actually a DARPA project. Who knew? Right? Then that becomes one of the requirements. Right? Like, hey, we want something for Department of State for foreign policy. It's like this has to be in this form or support this type of platform so we can use it. And then that goes into other stuff. The other bit I think is a cultural change, right? Because clearly, like the computer science, particularly Python, it's all over the place. Not so much in Java, or C, even worse in C. But it's that cultural dynamic. So I think if enough researchers, you get that density where enough researchers are doing this, then hopefully that cultural change will come into place. I cannot tell you how that culture emerged in like the bioinformatics communities, or I think TensorFlow and Scikit-learn are actually both run by Google. So maybe you just need a patron, right? No, they're not. So
TensorFlow was Google's, Scikit-learn is not.
Okay. So so if you get a patron that's like, hey, if you get that business connection where they want other people to do it, then that might be a way to catalyze it. Maybe the military-industrial complex. So the answer is I don't know, but hopefully it's been done before, and I think from the military, there's maybe mechanisms that could do it. I think if people start using it for business, right, and it gets the same kind of attention like TensorFlow and stuff does, then I think they will.
But then you have this businesses. Can we turn off the
Oh yeah.